Good morning everybody, I am Sridharreddy. Today my topic is dipole moment, which is important for IB examination as well as the competitive examination. Let us take, I am taking one molecule is called as the HCl. HCl, if you observe, HCl is held by a covalent bond. Why it will have the covalent bond? If you observe, the electronegative difference between the hydrogen and chlorine is less than 1.7. If it is more than 1.7, it is held by the ionic bond, but it is less than 1.7. That's why it will have the covalent bond. What is the covalent bond? A mutual sharing of electron. Due to this, a bond formed is called the covalent bond. Ultimately, in HCl, hydrogen contributes 1 electron, chlorine contributes 1 electron. Now, this pair of electron mutually shared between the two atoms. Ultimately, you will get the HCl. You will get. Ultimately, this mutual sharing of electron will be present in between the H and the chlorine. But actually, if you observe, the electron will be nearer to the chlorine like this. Why the electrons is nearer to the chlorine? Because chlorine is the high electronegative element as compared to the hydrogen. Ultimately, it drags the electron towards itself. Ultimately, chlorine will get the partial negative charge, hydrogen will get the partial positive charge you will get, and this molecule is called the dipole molecule. Why it is called the dipole? Di nothing but two, pole nothing but positive and the negative charge. This type of dipole nature is called the polar molecule. Ultimately, HCl is a polar molecule which will have the some short the ionic nature also, because it is a covalent bond. Even though it has the ionic nature, because electronegative difference is there, that's why chlorine drags the electron towards itself. That's why chlorine will get the partial negative charge, hydrogen will get the partial positive charge. Ultimately, the molecule is called the dipole molecule, and this dipole arises due to the polarity you are getting, and this dipole molecule will have the one phenomena that is called the dipole moment. What is the dipole moment? Dipole moment is represented with the mu, and it is the product of the charge on the either of the ion into the distance between the two ions. Distance, if you take H and L, the distance if you observe L, immediately the product of the charge of the one of the charges you are having, and product of the L, nothing but delta into L, nothing but it is a product of the charge on the either of the ion and the distance between the two ions. And the mu, if you observe, the units are the dBi. 1 dBi is equal to how much? 10 to the power of minus 18 ESU into centimeter. Very, very important. 3.33 into 10 to the power of minus 30 coulomb into meter. This is a CGS system, this is a SI system. Coulomb into meter, the value is 3.33 into 10 to the power of minus 30. Generally, whenever he asks you the dipole moment is represented with the 1 dBi. 1 dBi is equal to 10 to the power of minus 18 ESU into centimeter. 3.33 into 10 to the power of minus 30 coulombs and the meters. How to calculate the mu value? How to calculate the mu value? Mu value can be calculated by taking the product of the charge on the either of the ion and the distance between the two ions here having. Immediately, some important features are the dipole moment. If you observe, which will have the dipole moment, how to calculate the dipole moment if you observe. Let us take it. AB2 molecule which will have the linear structure. AB2 molecule with the linear structure. Those molecule dipole moment is the 0. For example, carbon dioxide, beryllium chloride. AB2, nothing but look at here, CO2, BeCl2. They will have the linear structure. With the linear structure, that's why CO2 will have the mu is equal, dipole moment will be equal to 0. Let us take it. Carbon dioxide like this. Let us take it. Another important small point I will give you here. Dipole moment is a vector quantity, and it will have the direction, and the dipole moment is represented with the arrow, and the arrow starts with the positive to negative. It starts with the positive and ends with the negative. That's why let us take here. Here I am taking the carbon, oxygen. Oxygen is a highly negative charge. Carbon is the partial positive charge. This oxygen also will have the negative charge. Always it is represented with the arrow starts with the positive negative. So positive to negative. Here also positive to negative. Now look at here how these two are equal and opposite direction. If it is the plus 5, ultimately it is also equal to the minus 5. So net value will be equal to 0. That's why any molecule which will have the AB2 structure, AB2 molecule with the linear structure, dipole moment is equal to the 0. Number 3. AB3 molecule with the planar triangle, then the mu is equal to 0. BCl3, BF3 if you take, they will have. AB4 molecule with a tetrahedral structure, mu is equal to 0. Best example, CCl4, methane if you observe, they will have the sp3 hybridization, AB4 nothing but 4, sp3 hybridization, tetrahedral nature, then they will have the 0 because they are equal in the opposite direction, just like the carbon dioxide, ultimately mu will be equal to the 0 you will get. Number 2, if you observe the trans and the cis molecule, trans and the cis. What is the trans and what is the cis? In the organic chemistry you will get. Whenever you are having the double bond, let us take here. I am taking one molecule like this. Same molecule I am taking like this. You observe the difference. Here, 2 chlorines are same side of the double bond. 2 chlorines are the opposite direction of the double bond. Same groups are present on the same side of the double bond, then the compound is called as the cis compound. Same groups are present in the opposite direction of the double bond, then it is called as the trans. If you observe, trans will have the dipole moment is equal to 0. Trans molecule will have the dipole molecule will be equal to dipole nature is equal to 0 because they are having equal and opposite direction, that's why net value will be equal to 0. Number 3, ortho, meta, para compounds if you observe. In organic chemistry, ortho compound, para compound, meta compound. What is the ortho? Let us take here. I am taking the benzene, chlorine, and this position is called as the ortho compound. If you observe this chlorine position is called as the meta. If you observe same compound, the difference is the position of the chlorine. If you observe, they are quite reverse, which is called as the para. Ortho compound, meta compound, para compound. So he asks in your examination, arrange the increasing order of their dipole moment. Immediately you can say ortho will have the more than the meta and the para, where the para mu is equal to 0 because they are quite reverse and the opposite direction. That's why the mu dipole moment of the para compound will be 0. Ortho will have the more dipole moment than the meta and the para. Ultimately para will have the 0 you will get. And the fourth one, whenever you are having this molecule, AB2 molecule will have the linear molecule, U is equal to 0. AB3 molecule with the planar triangle, mu is equal to 0. AB4 molecule with the tetrahedral, mu is equal to 0. Cis and the trans will have the 0. Ortho, meta, para, if you take para will have mu is equal to 0. Next, number of lone pairs increases. Number of lone pairs increases, dipole moment also increases. For example, water and ammonia. Water has the 2 lone pair, nothing but on the oxygen atom we have 2 lone pair. Ammonia, nitrogen will have 1 lone pair. Now, which will have the high dipole moment, nothing but water will have the high dipole moment than the ammonia because ammonia is held by only 1 lone pair. Here oxygen, water molecule, if you observe, oxygen has the 2 lone pair increases, dipole moment also increases.